Okay, then we've hit the 155. While we allow the rest of our colleagues to join, we can start with going over the agenda. So first of all, I want to give you a welcome to this webinar. We hope you will pick up interesting stuff. We think it's a very interesting subject ourselves. As you know, in recent months, we've had an energy crisis. And during the energy crisis, electricity markets have become a hot topic again, with several people questioning the market designs, etc. So do the markets do what they need to do? Are they still appropriate in their design for what is asked from them today? And in this webinar, we're going to touch on several very relevant topics in this matter. So we'll start with an introduction from the Irish NGN and the Belgian NGN to give you an overview of what CIGRE, the next generation networks, do and why you should join. Then we're going to continue with the presentation on capacity markets. And the last presentation is from Stefan Kaminski on the marginal cost pricing with a high penetration of renewable energy systems. In this webinar, we have a long time for question and answers. So please feel free to ask your questions. You can put them in the box. You should see at the top of your screen a Q&A option. And please, when you ask a question directly to one of the speakers or to both, and if you see a question you like, please like it also in the Q&A section so we can bump up the questions that catch the most interest. Anything else? Yes, I also want to mention that the webinar will be available online later on. So do not worry if you don't catch everything. You'll definitely find a link for a recording online. And we're still a bit ahead of schedule, so we can wait for the rest of the people to join. Okay, to keep your mind off the European elections, we can start the webinar. Maybe you can already share your screen, Keith, for the introduction of the Irish NGN.
Yeah, no problem, Oscar. I'll do that now. Let me know if you see my screen. Yeah?
Yes, perfectly.
All good. Good afternoon, everyone. My name is Keith Keedy. I'm the chairperson of the CIGRE Ireland NGN. I suppose I joined CIGRE in 2018 with the NGN, done, I suppose, various roles within the NGN. So I kind of worked my way up to chairperson at the minute. So I'm just going to give you a brief introduction on the Irish chapter, I suppose, of the Next Generation Network. So I will just move the slide to just a brief agenda. What is the Next Generation Network? An overview, I suppose, of our committee, some sample events held lately. Just a bit of on the Paris session, which is kind of coming up in August as well from the previous session, and NGN members participating in it. And then just a bit of our membership overview and stuff like that, and how you can kind of join, I suppose. Just on the Next Generation Network, I suppose for myself, I was trying to come up with a couple of lines, I suppose, and what kind of summarizes best. But I suppose it's kind of an area where it allows young professionals under the age of 35 to develop their knowledge in the power system industry through events like today, site visits. So 2 of the photos at the bottom are from 2 site visits our NGN attended late last year. So the Dublin Waste Energy event and Mount Lucas Wind Farm in County Offaly. So I'll touch on them in a later slide. It also allows valuable networking opportunities, I suppose, between peer-to-peer, but also from, say, the older generations that are within CIGRE to the newer generations, that knowledge transfer, I suppose, and get involved in working groups and stuff like that and producing technical brochures. It also provides a platform for early career professionals to feel, I suppose, comfortable sharing their ideas, presenting on their own work, I suppose, in their own fields, and getting interaction with industry experts. So it's a really good platform, I suppose, for young professionals to get involved in CIGRE at an earlier career stage, I suppose. And so, like the older generation, I suppose, they will be coming to retirement. So the big kind of focus is on knowledge transfer as well. So that's where the NGN was developed, I suppose, to get young professionals into CIGRE, I suppose, at an earlier career stage. Just a bit on our overview of our committee. So we have quite a large committee. We have 10 members at the minute. So we did break it up into 5 sub-committees itself, 2 event teams, 1 general membership, 1 student membership, and 1 communications team. So I suppose each person in our committee is assigned to, at minimum, 2 of these. And that kind of allowed for more kind of progress on a lot of fronts, I suppose. Everyone got something to do, easier to organise meetings, I suppose, in a smaller niche group, so you can organise study or subcommittee groups or meetings, so it's easier to kind of attendance. It's hard to get 10 people in a room at one stage. We do capture a lot of organisations within our committee members, I suppose. Supernode, HNMV, AirGrid, and ESB. So it's quite diverse. But I think that's the way we've felt that this is the best way to progress, with breaking it up into study committees itself, or study subcommittees, I suppose. Just on the latest, I suppose, events, and I touched on them at the earlier slides. So the Dublin Waste Energy event we held in, I think it's January, early January. So just a bit on that, we had 25 members on the day. The facility itself caters for about 600,000 tonnes of waste every year, and that's obviously transformed into electricity for the grid. So the waste inspected, weighed, and then combusted, and then obviously the emissions then are filtered through a filtration system. So that was one of them, and we got a good tour visit, I suppose, of all the different components and sections within that building itself or facility. The next one then, I suppose, is the next generation presentation competition, with the winner to present at the Paris session this August. So we had 4 or 5 participants, I suppose, from various kind of organizations, and then they were kind of presenting on different kind of valuable insights in their own respective study committees, I suppose. So it gave them a chance to present, I suppose, to an audience, get feedback from the judges, and on their presentation, how you deliver a presentation and stuff like that. So it was a really good opportunity. And from the start, when I mentioned that CIGRE is trying to give, or the NGN is trying to give platforms for young professionals to give presentations on their work and showcase their talents or whatever. So our winner was Manuel Hurtado, so he'll be representing Ireland at the Paris session this year. This one, I suppose, is our latest one that was in April. So it was a collaboration event with IEEE PES, which is the Power Energy Society, and the subcommittee of Women in Power. So this is a hybrid event, which the hybrid element of it, I suppose, in person was in KTH in Sweden. So this is a collaboration event between the IEEE PES Women in Power, the UK NGN, and Sweden NGN. So the in-person part was in Sweden. So we had 4 excellent presenters, I suppose, on the day. And it was all on the energy systems of the future and how we adapt to more renewables of the system, and the, I suppose, development of new technologies and how we combine these, I suppose, for the future development of the grid, I suppose. We had Louise O'Flanagan as an Irish representative. She is head of engineering and asset management in AirGrid, which is the TSO in Ireland. And then we also had Robert Finlan, who is our NGN secretary, given, say, a brief introduction similar to myself today on the Irish chapter. So just a bit on those, that all of those recordings are on our YouTube channel, or they'll be on by the end of this week. So that's CIGRE Ireland NGN if anyone wants to revisit those and have a look at more information, I suppose. Now, nearly there. That was just a couple of, this is just a couple of images, I suppose, of the NGN committee presenting at Paris last year. So poster sessions, tutorials, and group discussion meetings. So it shows you that the NGN is there for allowing young professionals to give kind of presentations on a global scale. So it just shows the kind of NGN, the platform they provide, I suppose. Just on our NGN membership itself, if there's anyone on the call that wants to join CIGRE Ireland, so we have a student membership QR code and a young members QR code. So the student membership is free. So if you do want to, you can scan now and brings it through it, or else you can visit CIGRE Ireland website and you can go through the drop downs, I suppose, for membership to go through that. We are trying to encourage involvement from colleges on the way, so students is a big focus. So if you are looking at joining CIGRE, or like, I suppose, the presentations from here on, please do reach out. You can reach out to CIGRE Ireland NGN at gmail.com as well for any more information. But look, that's it for me, and I hope everyone that's on the call enjoys the next couple of presentations. Thanks.
Thank you very much, Keith. Very interesting. Now we can go over to the introduction of the Belgium NGN by Giacomo Bastianel.
Great. Okay. Thanks, Keith, for the nice presentation, and I will do essentially the same for the CIGRE Belgium NGN. So, as you can see, yeah, I'm Giacomo Bastianel, chair of CIGRE Belgium NGN. I'm a PhD student for KU Leuven and Edge by NLV. So, yeah, in this presentation, I will quickly touch upon these points, mission and goals, our steering committee, what we did so far to increase the members, some events we did, some events we will do this year, and then some contacts that in which you might be interested. So our mission and goals is essentially, our group started in September 2021. There was a first steering committee and we had the second one. So it's my second year here. And what we've been trying to do in this time was to form a group of younger professionals and academics to give them a chance to present their work to other early career, because normally as academics we do it pretty often, but then people in the industry, they don't have that chance that often. So we wanted to give people this chance, but also act as a connection with CIGRE in Paris, CIGRE NGN International, and also organize events with other CIGRE NGN groups, as you see today, essentially. We also try to organize and promote activities, as you can see from the slides, technical visits, tutorials, and workshops, and I will touch upon them later in the slides, but also, yeah, try to involve several groups from other countries to do so. As you can see, CIGRE is a pretty big organization, it's Paris-based, but now it's expanded all over the world. And as you can see, also the NGN did the same, essentially. So we are proudly in Belgium in this small red circle, but as you can see, it's basically everywhere in the world. And in our steering committee, we started in September 2021 with KU Leuven people, and as you can see, it's still KU Leuven based. 4 out of 5 people are from KU Leuven, but we luckily have our vice chair, Stan, that is from a consultancy in Leuven. We would like to bring CIGRE NGN Belgium also outside the Leuven, so please, if you're interested in joining, please reach out to us. There will be a new steering committee next year. But also, if you're interested just for a talk or for organizing an event, please reach out, because we're really open to that. Members-wise, as mentioned, we are mainly KU Leuven based. You see it's a big blue portion there. We also have a pretty strong connection with Elia, the Belgian TSO. But as you can see, since 2022, we managed to get plus 29 members, and 21 are from the industry. So it's pretty, we like to say that we are growing in terms of industry people. And also we will launch soon 23 registration for this year. So please reach out to us, probably on LinkedIn, and by email we will send the registration link, because It's worth 88 euros, if I remember well, for 2 years, the free registration. So please, if you're interested in our events, yeah, register. For the events that we had in 2023, we had a joint webinar with CIGRE NGN in the Netherlands, joint event with CIGRE Belgium, and a presentation competition, as our the CIGRE NGN group from Ireland did. And in 2024, we had a webinar with CIGRE NGN Denmark, this webinar, but also there will be 2 technical visits in different locations in Belgium. We will give information soon about that, but we already confirmed the 2 of them, one in offshore substation construction yard, and the second one in a battery installation. On top of that, we will also host our annual presentation competition in November 2024. In addition, last slide, it's a connection with the CIGRE Award. We have open call for articles to Electra magazine, but also we are deeply involved in, I would say, yeah, CIGRE working groups as NGN members. You see here there are 4 NGN members that joined the working groups, but I believe also that yeah, new working groups are formed, and our NGN members already joined 2 of them, if I remember well. Plus, there will be our presence in CIGRE Paris session with 2 NGN members that were accepted for the NGN presentation. You see one here, Oscar, and also the winner of our presentation competition, Eros, plus 2 other members from the steering committee will attend the session, and also 4 NGN members who will present their papers in the proper CIGRE Paris session. If you wanted to follow us on our socials or reach out to us, please contact us, send an email to this address, or just give us a follow on LinkedIn. So I'm done with the presentation, I guess.
Yes, okay.
Back to Oscar.
Thank you, Giacomo. Then we can go over to the presentations. I want to repeat that if you have questions, please ask them. You can see the Q&A button at the top of your screen. And if you ask a question, please direct them at the speaker, and we can treat them after the presentation. We have a long time for question and answers. And then we can go over to Egon Downey, who will give us an overview of capacity markets, the good, the bad, and the ugly. So please, the floor is yours.
Thank you. So can you see my slides there? Yeah. Okay, great. Well, thanks very much. My name is Egon Downey. I'm the capacity market lead for Airgreen Sony in Ireland, and also for Northern Ireland. I'd just like to thank you for the NGN for inviting me to speak today. It's a great organization, CIGRE. I've been involved in it since I think 2007. And I've, over the course of my career, I've found it extremely useful to be able to interact with people across the world. It's amazing the resource of expertise that you get with CIGRE, and the just the depth of knowledge is incredible. So I think from my perspective, it's really helped me over the course of my career in terms of learning about all aspects of the power system. I've been involved in the C5 group for a number of years now, but again, it's great to see the full breadth of all the aspects of the power system are considered. So I think from a point of view of the NGN as well as the guys have gone through there, lots of really good, interesting activities going on. So great to be a part of that. So in terms of my own experience, I've been working in the area of capacity markets for a large chunk of the last 20 years. I've been working with EirGrid, in particular around the design and development and operation of capacity markets. So it's something that I suppose I have a number of experience in. I've been working in this current version of the capacity market for about the last 5 years, and I've also been involved in the design and development of the Renewable Electricity Support Scheme in Ireland and the establishment of the first Renewable Electricity Support Scheme. So that's just a little bit of background, I suppose, for myself. So I've basically entitled this "The Good, the Bad, and the Ugly." So I just maybe some caveats in relation to this. So oops, can you still see that? No, it's gone, is it? Okay, sorry.
Yes, perfect.
So is that in presentation mode, yeah? Yeah. Okay, sorry. Yeah. So just some important caveats here. Just I suppose this is from my own experience in terms of this area. It doesn't represent the views, I suppose, of the system operators in terms of capacity markets. The presentation is it's light in tone in terms of obviously it's some of this stuff can be quite dry in the topics in nature. So I've tried to make it a little bit more interesting in terms of slides. But obviously the reliability of power system is something that we take very, very seriously. So just important to bear in mind. And then also just in terms of the characters in the slides and their various attributes are kind of fictional in nature, so they're not representative of actual characters, but they're there as a kind of a tool, I suppose, to explain the different considerations in terms of capacity markets and how you approach it. And so hopefully, well, it's important to remember this as we go through. So in terms of capacity markets, so just an initial thing, like basically I appreciate people are coming from all sorts of backgrounds here in terms of the attendance. Some people may or may not have any experience with electricity markets. And so in terms of basic capacity markets, basically I've just included this point about why do we bother with them at all in terms of, because in terms of in electricity, when you're the trading of commodities, with other things in life, we could buy a product, we buy the thing itself, the prices that we pay is for the thing itself, and we don't have to kind of pay for capacity markets for other types of products. We just if we want to buy some food, we go to the shop, we buy it. If we want this for commodities, you pay the spot price for the commodity. And for, like, say, for instance, for shoes, for example, I've included here as an example. We don't have a capacity market for shoes, right? So why is electricity different, right, from, say, the global supply of shoes, and in terms of these differences? So so in terms of the very good reasons why we have capacity markets, and there's always a lot of debate around this particular topic as to whether they're needed or not. But in terms of the reason why we have them is because of certain characteristics associated with electricity, right? So one of them is in terms of storage, right? So in terms of shoes, right, you can easily store shoes, right? So as people probably know from their own wardrobes at home, or there's basically they're things that are easy to store. It's hard to store electricity, right? So especially at a large scale. Now this is obviously changing with the development of battery technology, but it's still very hard to. So we don't generate electricity and ship it around the world in terms of on container ships, because it's difficult to store, right? So we generally serve demand locally. Ease of transport, so it's also difficult to transport electricity. Now you need a lot of infrastructure to do that, and so again, whereas the market for electricity for shoes, right, basically is from all over the world, and anybody can set up a manufacturing plant for shoes and sell them to the rest of the world. With electricity, you don't see that, right? So generally, people who are serving the demand tend to be based locally. Obviously, there's interconnection and transmission can increase that, and that's obviously something that's very important as we go forward. As was the storage, because of the variability of, say, the resources coming through electricity. Demand responsiveness is another area. So in terms of this characteristic, so normally if you went to buy a pair of shoes and the price had gone up by 10 that particular day, so instead of being 50 euros, it was 500 euros, you would probably not buy shoes that day. You'd probably say, maybe I'll hold off and buy my shoes tomorrow. So in terms of electricity, especially, say, at domestic scale, oftentimes the responsiveness of demand to change in prices can be low. So for instance, you might be using electricity now at this point in time, but in terms of what is the price of electricity right now, it potentially is quite high, and because of the way metering works and so on in the system, that can mean that end customers aren't facing the wholesale marginal price of electricity at every point in time. Now that is changing, and that's something that with smart meters are in terms across the whole system, will mean that, you know, demand is more responsive, and we'll all be kind of, we'll all have more visibility of price, and that's something that's a very important area. But historically, that hasn't been the case. So that those kind of things together, basically, the storage, the inability to store it, and the lack of demand response means that you have to basically, electricity is effectively the ultimate just-in-time delivery system, right? So we could turn on a light switch and it's delivered instantaneously. And this is a very, very particular aspect of electricity, and it means that it can be incredibly volatile when you compare it to other markets. So for example, you take, say, for instance, a commodity like oil, or pork bellies, or shoes in this case, you would never see basically changes in prices of, you know, 6-fold changes in price over a course of a day, right? Or 10-fold prices over a day. Electricity price can change 100-fold over the course of the day. Now that would be very extreme circumstances, but it wouldn't be unusual for electricity prices to change by an order of magnitude across the day, which means that they are, relatively speaking, very volatile. And that's because of the fact that it's difficult to store electricity, and demand doesn't respond as much as it would be to other in other areas. So that leads to market price volatility. It also leads to market power. Now, you know, market power is simply basically where you have high concentrations in a market, and where that competition is lower, right? And that can basically mean that so market power basically can arise, especially in real time. You can have increase in terms of market power. So this can lead to concerns that prices are too high, right? By you know, and so this could be either they're too high in the value placed on them by customers, or the amount is above what would be considered competitive levels. And so that introduces the need for regulation, which is basically ways in which you would manage the risks of artificially non-competitive prices. And this can be in the form of price caps or short-run marginal cost when bidding principles. These are various different things. There's a raft of other things that can happen in terms of regulation. And what that results in is that leads to this concept of missing money, right? So if you have short-run marginal cost bidding principles, for example, where basically, you know, participants in an electricity market have to offer in their short marginal cost, which is basically their fuel costs or their operational costs. It's not their capital costs. Then this means that they can't recover the capital cost of the projects from the spot market. And so this creates this concept of missing money, right? So missing money is basically means that there's not enough money in the actual spot price to recover the investment in capital that's required for, say, to build new generation, right? So this means that the conditions in electricity markets can be poor for investment in new capacity. So the volatility of the price, and then the fact that it's regulated to protect consumers against market power and various different other things, creates the conditions where the actual investment can be low, right? So this is where capacity markets comes in. So I'll introduce our first character here. This is the bad, right? Angel Eyes, right? He's a fairly ruthless character, and this guy he's interested in basically himself pretty much, and basically taking advantage of situations, right? And so he likes volatility, and he likes the fact that maybe there's you know, potentially reduced investment and there's no new entrants coming in, and that suits him. What I've included here is basically a slide from, or a graph. This is from the 20th. I appreciate the text is quite small on parts of it, so I'll just read it out in terms. This is from the week from May the 20th to May the 26th of this year, so just a couple of weeks ago. And this shows in grey you have. In green, you have the demand in Northern Ireland, or sorry, not demand. This is the trading on the day-ahead market, where most of the volume of electricity is traded. So you have the green is Northern Ireland, the grey is Ireland in terms of volume, right? So that's the bar graphs. This is over the course of a week. So you can see there, this is your kind of a demand profile bar, and you can see the daytime demand. during the week, and then you can see the weekend slightly lower. And now this is not all the demand, but it would generally be a large, like pretty much most of it. So this would be quite indicative of demand. And you can see then in purple is the GB price, and then in red is the SEM price, the single electricity market price for Ireland and Northern Ireland. This is the wholesale electricity market. This is not the capacity market. This is just spot market. And then you can see here, just below it is the wind output, right? So you can see here that this is the green line is the forecast, 15-minute forecast, and you can see the red line is the actual wind, right? So you can see here we have basically 5 gigawatts, a little bit more than 5 gigawatts, and then we have upwards of 3.5 gigawatts of wind appearing onto the system and then leaving the system and coming back again. So you can see here that this creates basically price volatility, and you can see, and this is coming from the physical volatility of the resources, and we're having to balance that out. And so you can see here the price basically on the, I think that's the Wednesday, basically drops very low, but then it comes back up quite high on the Thursday, right? So you can see here that this is this volatility. So going from, say, 25 euros up to 175 euros, that's a 7-fold increase in price, and this would not be unusual in terms of. So this is the kind of thing that's in terms of. This would be a normal. This would not be excessively volatile, and this would be a normal kind of feature of a lot of electricity markets. And but this guy, he wants to see. He's looking for basically opportunities where he's hoping the price will go much higher, right? So he says these villagers, they could do nothing about it, right? So he thinks he's looking to take advantage of the situation, right? Now, obviously, this is a fictional situation I'm representing here, right? In terms of, I just want to emphasize, right? In fact, what I'm going to go through here is just how we mitigate, right, this kind of this from the market by basically strong regulation, enforceable rules are in place, right? So I want to emphasize that. But basically, these guys are there to make money. And this particular character, he's interested in, he's quite ruthless, right? So he's looking for this situation, right? But then you have entered the goods, and this is the new entrant, right? So this is Blondie. He's a good guy. And he arrives in and he says, basically, I don't want to. I'm not going to be trying to take advantage of these people. I just want to cover my room board and a little sipping whiskey. So he just wants to basically cover his costs, right, and have a revenue. Pay him. You got to pay him a wage, right, and he will protect you from these bandit prices, right? So the bad is trying to bring in. So this is effectively what the capacity market does, right? It basically pays out a flat rate to a generator, and so customers pay that, and in exchange they get protection from high prices. So this whoever takes on the obligation, they get paid that money, and they basically all in return for stable revenue. So this is so basically this is a strong incentive to generate there when the high price happens, and if not, they pay replacement. So just in terms of time wise, how am I doing for time in terms of
Good, we have some buffer, so
okay.
Go ahead.
I'll keep moving. So
we're basically very interested in the story.
Yeah, so this is so then basically, then the ugly turns up, right? This is Tuco. For those of you, hopefully some of you have seen this movie. It's a good movie if you haven't. But basically, Tuco turns up, and then Tuco is an opportunist, right? He is kind of a guy that he just tries to get away with stuff, and he's looking for. So he says somebody say something about whiskey, so he's interested, right, just in anything that's going, right. So and he thinks, well, maybe the going gets tough, I can get out of here, right. That's, I don't really have to, I could try and take the money, right. But then he sees, oh, there's a sheriff in town, and maybe he needs to think about this, right. So these are the kind of, so basically then Angel Eyes, he says, this looks like a lot of hard work, right. I don't know if I can you know, the high prices, the opportunities that were there. I'm not sure this capacity market does this for me, because it's you know, it seems to be too much hard work, right? So he decides to go, right? So basically, the point of all of this is that you really, in terms of design of capacity markets and in markets in general, you need to basically design the markets to basically mitigate against basically the kind of characteristics that some of these characters have, right? And basically, and to attract the characteristics of you know, the more kind of desirable, prudent, well-run projects, right? So in terms of reliability, right, we have a number of different things: reliability, risk aversion, competency, trustworthiness, self-interest, and kind of ruthlessness, right? So these are kind of things where, you know, in terms of the integrity of market arrangements and basically the protection systems, you need to make sure, right, that you kind of are, on one hand, putting in place strong measures, right, to protect against, say, various undesirable characters, but also that you don't kind of throw the baby out of the bathwater. You don't actually, in doing so, remove the conditions for investment, right? So like in terms of reliability, risk aversion. So the good is he's very reliable, he's risk averse. He doesn't get into situations that he can't handle, and he's very competent. But the bad is also in that he's similar to that, right? So he's kind of similar. So where they differ is basically on trustworthiness, self-interest, and ruthlessness, right? So, you know, the good is high on these ones and the bad is low, right? So and then in terms of the ugly, he's kind of low across the board, right? So he's got low on reliability. He's not risk averse at all. He's a kind of gambler, so he'll go in and try anything. And then in terms of competencies, low levels of competency, not trustworthy, and he's got high levels of self-interest, and he's kind of maybe less ruthless than the angel eyes. So he's so in terms of this, he basically means that in terms of design consideration for capacity markets, a level playing field for reliability is really important, you know, to establish, so that basically people can compete on the same thing, and it's visible how they're faring against basically their abilities. Risk aversion. So one of the key important thing with the capacity market is that if you make it too risky, you'll eliminate everybody, right? So you'll eliminate the good investor, but the other, he doesn't really care. So you'll end up with projects that are less prudent and possibly riskier projects if you make it too risky, right? So you have to put in a certain amount of performance requirements, right, in order to get delivery, to get the performance you need. However, if you go too much, right, prudent investors will not invest. They will actually say that's too risky for me. So it's important that you set those carefully, right, and so that they're not punitive and they're not overly risky. In terms of competency, basically, so you have to have qualification standards that eliminate that there's a basic set of requirements: grid code requirements, the ability to meet the trading and settlement code, the ability to meet the capacity market code. These are various things that are, and various qualification requirements to be able to show that they can deliver. So these are very important to eliminate basically projects that are just not, say, capable of meeting those various requirements, those standards, right? And then, so in terms of these remaining ones, explicit cost-based consequences, right? Cost-based consequences, right? Not punitive consequences, but cost-based to address poor performance. And insofar as possible, I'll jump to this last one, which is strong rules, right? So strong rules and the enforcement of them, clear, explicit, strong rules, and then being enforced by the sheriff, or in our case, myself. It would be is a necessary thing to have as part of the market, and that basically ensures that the projects that you come through are like in the good, right, category, and that you mitigate against these types of projects coming through where they're maybe opportunistic, or they're basically have their own interest of mind.
Egon, can I interrupt here? You have a lot of material left.
So I just have 2 more slides, right, and then I'll be quick.
Okay.
Okay. Yeah. Thanks.
We're
Oscar.
testing the risks of our time.
Sorry. Yeah, so the terrain, right? So just important as well to understand that the terrain is complex, right? So just outside of these kind of considerations, capacity market, we have planning, right, in terms of projects, better developed projects are more likely to see environmental constraints, connection to grid and gas, in terms of more complex connections, have longer lead times, supply chain for major equipment, and major global events, war, COVID, these things, right? They all impact on deliverability, and they're things that they can, these are outside of capacity markets to a certain extent, and it's hard to mitigate against some of these things in terms of so that's another factor that there's that important to remember. So basically the end of so conclusion. So again, these are just illustrations of basically how we approach the trying to ensure basically you get delivery in the capacity market. And these are a lot of things here I've experienced in different regards over the course of the last few years. And I think just the key thing is you have a diverse set of people that come to you, and having clear, explicit, enforceable rules and very good incentives aligned with customers' interests that are not overly risky are the key things, right, in terms of having a well-functioning capacity market. And this can be successful in attracting investment, but there's also difficulties in the terrain in terms of building large infrastructure, and this obviously takes time. Thank you. That's me.
Okay, thank you, Egon. Very interesting way to approach the subject. Very interesting. So then we can move on to Stefan Kaminski, who will tell us more about marginal cost pricing and capacity remuneration mechanisms. So the floor is yours.
Perfect. I assume you can see my screen?
Yes, perfectly.
Amazing. Thank you very much. First of all, thank you very much for the invite, and very much appreciate the opportunity to present with you guys here. As most of the organizers, I'm an alumni I've done my PhD at KU Leuven. And now I work for NG Impact, and I have to give a little disclaimer. So the views that I'm going to present are my own views from a research perspective, so they don't necessarily reflect what NG thinks. What we're going to do today is I structured my presentation into blocks to pick up everything, to make it graspable for everything. I would like first to explain why electricity markets work with marginal cost pricing, to explain why marginal cost pricing is the one and only way to procure electricity efficiently. And with that, I would also like to connect to current events that the market design is being questioned by average cost pricing. And I would like to explain a little bit around that. And then I would like to basically rephrase what Egon impressively said. Why do we need capacity remuneration mechanisms? Why is it needed even from a theoretical standpoint? And then I would like to connect everything to the current involvement of the system, that we have higher penetrations of green electricity. And I would like to address the question whether CRMs are still needed in those systems where we have higher shares of VERAs, or whether they could even be used to promote those higher shares of renewables. So first of all, okay, why is the market working with the marginal cost pricing? For that, I would like to start at the very beginning. I would like to give an example that's unrelated of the electricity market. So it can be explained with any kind of good. Being situated in Belgium now for 6 years, I had the choice between picking potatoes or maybe beer. I might go for this reason with potatoes. So if I was a vendor and if I was looking on the, let's say, weak market to buy a certain amount of potatoes, being rather structured, I would proceed as follows. I would look around to the different vendors. I would ask the different sellers for the prices, for the quantities that they have. So as I'm a big seller, I would like to buy a lot of potatoes. So one reseller won't be enough. So I need to ask for different prices. They will tell me how many potatoes they have and what they cost. And to procure or to spend a little amount of money, because I would like to earn money, I would start buying potatoes first with the cheapest reseller, buy everything from them. If I need more, I would continue buying with the next cheapest reseller, and so forth. This is actually also how the electricity market works on the, for example, day-ahead market. Here I printed out a marginal cost curve. Let me quickly find my pointer. Merit order curve, sorry, where the different steps here are generation plants. So it's C1 to Cn, where C1 has a marginal cost of 0, C2 is a little higher, and so forth. And the different x dimensions are the amount of electricity that can be produced at one time step. The demand curve now is occurring every hour, and electricity demand, so if it's cleared, there will be one intersection between the supply curve and the demand curve. And at this curve, the market will be cleared, which is basically the point that I just pointed out, where I have all my potato bought to the lowest price. The same happens on the electricity market. And the interesting point at the electricity market is that every participant receives the same price. In this case now, in this illustration, CI receives just its marginal cost of production. However, everybody on the left side receives some inframarginal rents, which are, at least in theory, being used to recover the big investment costs that they have. If the demand now speaks, so if the bad guys turn around the corner and would like to earn some money, the demand increases and the price would spike. In this case, we have some scarcity rent, which is above the marginal cost of the highest or of the most expensive power plant. This seems unintuitive, but this point is actually in a theoretical point needed, because this is the only point of time where the last power plant in the row can earn its money to recover the investment costs in order to have enough capacity in the system. And for that, we can also look at the long-term cost recovery. So I picked two random generators. One is on the left side, and the right one is the last one in the row. And here it becomes clear where the long-term cost recovery works. So on the left-hand side, there is all costs, being the fixed investment cost and the variable costs. So everything is recovered by the electricity market. And on the right side, it's broken down towards how to recover the investment cost. And here it becomes clear that power plants on the left-hand side, they are dependent on the inframarginal rent, but also the scarcity rent, those two blocks. While on the right-hand side, which I also explained already, the peak load unit is in an energy-only market just reliant on the scarcity rent to recover the capacity costs. In other words, if this peak demand doesn't occur, this peaking unit wouldn't have an incentive to actually install investment, and we would have a blackout, easily spoken. In terms of efficiency, this energy-only market is socially optimal. It can be mathematically proven. It has been done already in the 70s, so this is not really a secret. However, this is just assuming certain conditions, for example, perfect foresight, price-taking behavior, and so forth. However, this market procures optimal investment capacity, which is quite ideal, given that we are striving for providing electricity at the lowest costs for the consumers. Because of late events, I would like to pick up on average cost pricing. So when the invasion in the Ukraine started, we saw prices spiking even more than usual. Then we heard claims about that the electricity market is broken, and some people requested that we change the pricing scheme, that we would go for average cost pricing. I would like to explain why this is not a good idea. So in average cost pricing, there are different approaches. And a very simple one now is that the consumer pays an average cost, which is some kind of an average, or take an average over different prices, either temporal or local, or in one point of time over different providers. It doesn't really matter what it is. It doesn't reflect the marginal cost. So it's somehow below the marginal costs, and not as responsive as the marginal cost pricing. The producers, on the other hand, they receive the variable costs of their production any moment. However, they wouldn't receive direct payments regarding the investment, at least not directly. There is another instance, the general authority in the middle being needed to balance and to promote investment. And this can be seen also in the long-term cost recovery, where it can be seen that there are no inframarginal rents, because generators are directly remunerated their marginal costs with the average costs. But however, there are capacity payments needed to promote investments in this scheme. And this investments would be very plant-specific capacity payments, which would be regulatory set, and therefore in terms of efficiency aspects, most likely suboptimal. What comes on top of that is that the consumer incentives would be quite distorted because the consumer wouldn't see anymore the real marginal cost prices. It would see the average cost prices would be below the marginal cost of production, incentivizing higher consumption, which will in turn be more expensive for society. So maybe coming back to the actual storyline, I've shown at some point that energy-only markets in theory promote social optimal resource mixes. Why do we actually need CRMs? And this is a recap now of what Aegon did. There are in reality certain factors that are not considered in investment or not in this idealized investment theory. In reality, there are certain behavioral aspects, for example, the risk-averse investors that's often discussed, or there are some certain circumstances that prevent the price to rise high enough or fast enough to recover the needed investment of the peak load power plant. And those circumstances are discussed to lead to lack of investment in reliability, which can actually also be shown here. I did 2 simulations for risk aversion and for price restrictions that prevent the price to rise high enough. And it can be seen in both cases. I can't run through everything, but in both cases, we have a certain missing capacity taking a societal perspective. For that, there are capacity remuneration mechanisms implemented with the idea to bump up the installed capacity again up to social optimal level. So the aim of those capacity markets is to eliminate residual adequacy concerns, which easily translates into a lack of investments. So how do those CRMs work? So CRM is basically another market that complements the electricity market. And on this market, the product is capacity, more specifically, reliable capacity. The market works with 1 clearing per year. And it works like in electricity markets. There are some capacity providers and a capacity demand curve that's set by the operator. There is also a clearing point. And as electricity markets, this market is non-discriminatory, meaning all providers that are cleared receive the same remuneration in euros per megawatt for the capacity. In terms of long-term cost recovery, we can see now that the previously needed scarcity rent for the peak load power plants are replaced by a capacity payment that is done by the market. So the uncertain moment where the price peaks or not is not, it's being hedged by this market. This has some implications on the long-term cost recovery. You can see that the scarcity rent, which has been formerly here and here, is replaced by the capacity payment to hedge the risk for the providers, for the generation companies. And so this combination of energy only and capacity market is short-term efficient, and when well tuned, and I cannot emphasize this enough, just when well tuned, those 2 schemes, so comparing a setting with capacity market and without capacity market, trigger the same social optimal investment. So the question now is, okay, in principle, we have justified why we need CRMs. Does that still hold if we have an energy transition, if there are more renewables in the system? And for that, I would like to show you an illustration where I use the most simple optimization method, where I use the screening curve method. This method has 2 charts. On the lower side, you see a cost curve of illustrative 2 power plants, a baseload power plant, a peak load power plant, and the wall indicating when it makes economically sense to curtail energy. On the upper part, you see the load duration curve, which is basically the electricity demand ordered from high demands to low demands. And I would like to first show this approach with the thermal system, so neglecting renewables for now. To find the best generation mix, it can be seen down here already when it is the cheapest to run the baseload capacity and peak load capacity, and how much and how long electricity to curtail. This is directly the intersections here. Putting those up reveals how much base capacity, peak capacity, and energy not served appears in the system is social optimal. If there is no, some feature of the slides that I showed before, if, for example, the prices don't rise high enough, which I illustrated here now with the price cap that's below the willingness to pay of the consumers. In this case, the intersections change, and with that also the amount of peak capacity that would be installed. What can be seen here now is if there's some kind of distortion now, is that there is missing peak capacity to too little peak in the system. The CRM would counteract that now, and obviously for this illustration, I tuned it ideally. In a CRM, as I mentioned, every provider receives the same euro per megawatt payment for reliable capacity, which moves these cost curves to the negative y direction, idealized, moving back the intersection to the right point and vanishing the capacity to have, again, the social optimal investment mix. Looking at a system with high renewable shares, the slow duration curve would change. In this curve, this curve was considered the residual demand curve now, deducting everything that has been produced from renewables from the actual demand. The message is basically that, okay, the same approach, and I go back so you can see it, the same approach could be deployed again to the system, indicating still that there is some capacity missing. So REST technologies, maybe to mention that as well, REST technologies, so not everybody has to participate in the capacity market. They can also opt out of the system, or they can opt in. If you opt out, the capacity or the residual demand curve would be lower, because the residual demand curve of the renewables has to be considered. The main message is now that this missing capacity would still be there, because the underlying reason for capacity markets to exist hasn't been deleted, basically. So the underlying reason is still there, meaning that even with high shares of renewables, the capacity market would still be needed. Lastly, maybe even going a step further, I've been asked before this talk whether we should reuse, or whether we could reuse CRMs, repurpose is the right word, repurpose CRMs, so that they could actually even support high-risk penetrations. And my answer to that would be that CRMs are not designed to do so. They are, as dictated in the regulation, to support generation adequacy. For that, they pay back a reliable capacity. However, PV and wind, or the contribution of PV and wind in those moments, is very small. So those would actually not really play in the capacity market. To decarbonize the system, the main point are CO2 prices, or the main factor to do so, main instrument to do so are high CO2 prices, which support the decarbonization. And so if the CO2 price is high, going back to the merit order curve, the marginal cost of production of very dirty power plants would be higher, and those dirty power plants would be pushed out of the merit order curve, not producing anymore. And what happens in reality is that those high CO2 prices are even complemented with other renewable support schemes. And there are four main kinds that are being deployed in Europe, which are feed-in tariffs, feed-in premiums, green certificates, and investment grants, of which the European Commission prefers two-sided CFDs, which is basically a feed-in tariff complemented with PPA. Long story short, what I try to say here is that different objectives usually require different mechanisms, and repurposing a CRM to promote high shares of renewables is not advisable. In a box, the main conclusion is that the natural outcome of every market, whether it's a potato market or the energy market, is a marginal cost pricing scheme. Any regulatory interventions, for example, average cost pricing, will alter the system to be less efficient than marginal cost pricing. Then for renewables, if the system is higher penetrated by renewables, CRMs are still needed because the underlying reason still remains. And CRMs, this is really flatly explained, are not meant as renewable support schemes. They are meant to promote and ensure system adequacy. And with that, I'm also through, and thank you for your attention.
Very clear. Thank you, Stefan. Very interesting presentation. I see we have used up quite a bit of our time buffer, so we can quickly go through the questions. I saw a question from Robert Fendon, directed to Aegon. You mentioned that the market is largely impacted by several factors outside of the market control. So what would you see as the biggest challenge affecting this market from an Irish perspective?
Thanks, Robert, for the question. I think like all the items that I listed on the when I was going through the terrain piece about for projects, they can all have varying effects on projects depending on the type of project. So you know, for instance, in some cases, supply chain can be supply chain issues can be a problem. Sometimes where there's a complex gas connection or complex grid connection, these can be difficult. But I think one of the things about we would expect, I think, and we place in our capacity market, the risk is placed with the participant because they make the decision to where they locate the project. So we would expect them to actually, you know, to even though it is challenging, managing supply chain, you know, in terms of the availability of equipment and so forth and timelines, and also grid and gas, those things we, you know, that there's that in terms of managing that would be something they could do. Whereas something like planning is probably, I think, is a particularly tricky one because you know, the people can raise concerns and appeal planning, and that can take a long time, and sometimes that's an unknown in terms of timelines, you know, so that can really have a big impact on projects in a way that potentially a good prudent project may not be able to foresee or plan for that level. Obviously they can all do work on that, but I think planning is a tricky one. I think something that's you know, building large infrastructures is one area that can result in long delays. And then the other area I think is IED as well, as another kind of concern around basically units not being able to run for being limited in how much they can run for. You know, so because obviously the contribution to reliability, you know, is based on certain assumptions. You know, so derating factors are calculated based on running for 8760 hours, or you know, say a number of hours, and then if a unit is actually subject to quite strong restrictions from under IED to do with so like open cycle gas turbines, for example, under IED, that can have a big impact as well. So that's a big challenge, I think. You know, if I had to name one, it'd probably be planning. I think is probably the biggest one, maybe followed by missions permitting.
Okay, thank you very much. We can switch it up. Then a question for Stefan, one from myself. So you mentioned that the marginal pricing can be more responsive to the market or in the market than average cost pricing. Could you explain what that is, what you mean by that, how that
certainly.
out?
Sorry to not have been too clear with that. So the average cost pricing, it depends on what you average, but let's say we average on all the power plants that are producing in a specific hour, let's say 1 to 5. If the average cost scheme would be that way, that we average over the produced electricity, and for example, we would increase the threshold where power plant number 6 needs to ramp up, and we just use, it's not possible, but for illustration purpose, it's okay. We just use 1 watt of power plant number 6. In average cost pricing, the price would still stay constant, while in the merit order, in average cost pricing stays constant, and then marginal cost pricing, the price would directly reflect the marginal cost of the last power plant being much higher.
Okay, that's clear. Thanks. Then another question for Aegon. So 2 questions actually. So first of all, in your opinion, and without revealing the details, says the question asker, have you ever seen any examples of undesirable market participant behavior, specifically on the SEM, And is this very rare or a common thing?
Yeah, thanks, Ken. I think yeah, we would have seen. Over the course of my time working as the lead for the capacity market, I've ran basically about over 10 capacity auctions. We probably allocated about maybe over 9 billion euros worth of capacity payments in those auctions, and we have probably seen through the process quite a lot of different characters come forward in terms of the process. So sometimes a lot of information is published around the outcomes and so on. But there possibly are I think instances where you have maybe participants who would be a little bit more optimistic about what's possible than we would. So that would be quite common, where a participant says, well, we can do this in this time frame and deliver in this time frame, and we say we don't think so. Right, that's so that's something that we look at a lot. I think so that's in the risk piece, but I think over time the risk, I think in terms of getting the balance right between it being a sufficient risk to drive delivery, but not too much to actually deter people, right? That's the real balance you're trying to strike. That has actually seemed to have worked. Early on in the capacity market, we would have seen, say, a number of projects coming forward with very high levels, volumes expected to deliver, and a lot of that was terminated. But then when the actual the long stop dates were kind of tightened up around that, we saw basically that kind of a bit more discipline coming into those areas, yeah, I think just having the enforceable rules, when you have clear enforceable rules, you can actually apply them, and we've applied termination charges where we've taken millions of euros off people, which is very hard to do. In reality, people tend to not want to part with that kind of money, but because the rules have been quite robust, we found that actually they've been well behaved and gone in terms of when we've actually had to apply them, that it has people have accepted the outcome, and so hopefully that gives some answer to that question. I think there's a second. Is that second question?
Yeah, there's a second question indeed. So,
yeah, so
what areas do you think there's most need for additional signals to the market participants to encourage the good behavior, and when is the next review of the SEM market to be expected?
Yeah, so I think like from a point of view of good behavior, like it's very important to basically say as well. I think that when participants that have come forward with projects that I've seen, all of them they're operating quite challenging external conditions, right? So that the terrain is really a significant factor. So delays, and generally, for the most part, delays in projects, or in some cases terminations, have been a result of really very significant external factors. So I think that's really important to emphasize in terms of that a lot of these projects are been, for the most part, good, right? And I think so in terms of with the capacity market, it takes a long time for the actual results to start to come through, and I think it's really important to maintain stability. So in terms of rather than say trying to tweak it and change it and redesign it to try and kind of fix some things, I think that probably the balance is quite good there, but it'll take some time for it to come through, and that's so the investment in capacity takes a long time, and I think that if you kind of keep moving the rules around, basically investment kind of they lose kind of confidence and the certainty. Whereas if you maintain stability, basically people can it takes time to build up that investment appetite, and I think that so I would say just in terms of in a lot of extent, I think maintaining the kind of current market in its form, I think there is a good balance there. Whether there are some areas I think that Stefan kind of covered in his presentation about scarcity pricing. So I was involved in the design of scarcity pricing in the imbalance price, and I think having the probably making sure that those high prices and the incentives that come through that are coming through efficiently, so that way it drives the kind of necessary performance, in terms of that incentive. That's a key bit of our mechanism.
Okay, thank you very much. And then 2 more questions to Stefan, and I think we can wrap up after those. So Stefan, given that the intraday market in Europe is very volatile, what is the alternative to support the integration of renewables? Can capacity markets be adapted to the integration, or how do you see it?
Yeah, that's a bit of a question of a belief. So I believe capacity markets are designed to ensure generation adequacy. So for me, to ensure high penetrations of renewables, we need another market. And we actually have this kind of market. We have a CO2 market. We have a whole myriad of different markets that are overlaying this market. For example, in Belgium, you have the green certificates. You have some subsidies for investment. You have all kinds of things that are there. But the capacity market should be, in my perspective or from my view, there to promote a system generation adequacy.
Okay, and I think
I might come in on that as well, Oscar. Maybe I just, in terms of my perspective, I agree 100% Stefan's point there. Basically, that the incentivized renewables is a separate consideration, and that capacity markets are about reliability of the system. I would say, and I think Stefan did cover it as well, is that that's the integration of renewables, right? So having a high variable renewable system that's also reliable. The reliable element of it. So capacity markets can play a key role in that part of it, which is basically ensuring that whenever there's, like in my slides I showed where the wind dropped off, and it was that in those periods that there's sufficient capacity available to meet those periods, and so that it's on one hand, I think Stefan kind of pointed that there are mechanisms to promote renewables, but then the capacity market, the key thing is that it's key for integrating renewables to a reliable electricity supply.
Okay, thank you. And I think that the final question kind of links up to your answers, in that it seems that the prerogative to have a higher renewable energy penetration in the capacity market and the capacity market, that they are largely decoupled. So how would we influence the renewable targets then? You mentioned the carbon market, the ETS. Do the payments outside of the capacity markets compensate somehow for this, or how do you really get to those renewable targets then using markets?
For me, that's clearly a question of the ETS market, not of the capacity market. I mean, as Egan rightfully said, and I completely agree with that as well, the capacity market can be used to promote enough reliable capacity, maybe even pushing reserves at some point. There's something being considered right now in the legislation to level the playing field to allow more penetration of renewable systems. But I wouldn't use the capacity market directly to promote renewables.
Yeah, maybe just one maybe additional point is that there is a world which you could see, say, in the future where, like, a lot of times, like wind and solar are derated heavily in capacity markets because they tend to basically, first of all, they move all at the same time, so they're highly correlated. Oftentimes they're not correlated to the demand. So peak demand, for instance, when you turn on lights, often is at sunset. So, like, for example, in solar, it's the point where there's no sun, and so but as we move the demand, so a key thing with variable renewables is to actually move the demand to the resource, right? So using various technology like batteries and storage, and so so there is a world basically where you could have a very highly reliable system based on wind and solar, where you move essentially the demand to effectively so that the demand coincides with the output of those units. Now, obviously, that's a long-term perspective, but that's using cross-border capacity in terms of interconnection, using batteries, so where that in that situation you can envisage that. So in one set point you said that they're kind of decoupled. They're not independent necessarily, and it is important to say in capacity market design that it is sufficiently dynamic to reflect that basically the variable renewables element of it. So there's a really key kind of consideration about increasing levels of variable renewables as how they affect the overall system. You know, so they need to be talking to each other. You know, all the various different mechanisms.
Okay, thank you very much. Yeah, maybe one final question. So having more energy storage available could promote renewables. Can CRM be used to encourage investments in energy storage, you would think?
Like storage is one area which is it has many things that it does, right? So for instance, if it's to the extent that it's reliable, right, you can basically earn money in the capacity market, and to the extent that it can buy energy cheaply, and then sell it at times of higher price, then it can benefit from arbitrage in terms of energy markets. It can also sell system services. So when you look at the combination of those things, you know, that is, you know, we're already seeing a big increase in investment in storage coming through in terms of the pipeline, and there's and it's based on you know, the fact that it does all those various different things. It can buy the wind at cheap prices, and it can sell it during the when there's lack of wind or solar, and it can also respond quickly to fast frequency, you know, potentially synthetic inertia, these kind of things. These are obviously development things that are coming down the track, but even fast frequency, we would see a lot of that, and on all the various different reserve categories, so in that sense, the conditions are already there to promote that investment.
Maybe adding one minor point to that. I sorry interrupting you at the beginning. Yes, I just wanted to say yes, they can promote it. However, capacity markets are non-discriminatory, so we cannot promote a certain level of capacity of storages in there. There are also derating factors for those storages that they can participate.
Yeah.
Okay, very clear. So we are already over time. I want to thank everybody, especially the speakers, also the attendees, for very good questions. We had a very good, productive discussion. So I want to thank everybody. I will make sure that the recording is available, and I hope to see you all again at the next webinar.